My name is DaShaun Carter. I'm a Spring developer advocate. My computer is rebooting. I've been doing this for, I think it's 472 days in this role. Before this, I worked at Redis, and before that, I worked at Pivotal/VMware, and I was a VP of engineering for a little while, and before that, I was a tech lead for a company in Kansas City that I'm a big fan of. And I have scar tissue. Like I've done things along the way. I've had problems, probably similar to what you guys have done. I've had problems along the way, and the purpose of today's talk is really, I don't want you to run into those problems. The big thing, I'm going to go ahead and see if that'll boot up. The big thing is, I didn't come from a lot of money. I didn't have the cloud when I came into this industry, so it wasn't easy to get resiliency when you started to grow. So as things started to grow, does anybody remember my password? As things started to grow, as we started to scale, we started to run into problems. One of the things I hear, I get to travel, I get to work with a lot of Global 2000 and Fortune 500 companies. One of the things I hear a lot, it kind of makes me giggle, is we've never done a game day. Yeah, we have backups and we have resiliency, but we've never tested it. Anybody, does that sound familiar? No? Everybody here tests all their stuff all the time? Okay, that's awesome. This is a great crowd. The other thing is the idea that sometimes the things that we think aren't going to last, the little quick fixes that we do, sometimes they make it into production and they end up becoming critical. Does that ever happen? The company that I'm thinking about, I worked at about 10 years ago. I made a thing, I thought it was going to be temporary, and it's still there, and I know it's still there. I still have friends there. And just that idea, like, why? Why is that still there? I have lots of code that I'm not proud of. I have lots of code that I wouldn't share on a big screen, and that's okay. Like, this is a safe place. I feel really comfortable at this conference. This is a safe place. And one of the things, it would be nice, and I think maybe it's one of my problems, is I can't leave things alone. So you're going to see here, hopefully in a minute, the repository that I did, I was making changes up to like 20 minutes ago. So what could possibly go wrong? I'm going to try to get these up. Maybe, oh, it looks like I have a screen now. Just don't see it. It looks like my screen's working. Thanks, Daryl. Let's try it. Nope, it's still not going. That's okay, we'll wing it. We'll wing it. I'll do it this way. Yep, today is 473 days in this role, so let me correct myself. I'll scoot through my slides. But again, my children will never deploy active passive. Why? I've ran into these problems, and yeah, I don't want you to run into the same problems. So first, let's do a level set. The idea that we've got a zone. So I'm going to talk about, like, everybody understand like a zone and a region. A zone is where I've got compute, I've got network, I've got power and cooling. That's kind of like the three main things. If I've got all that, we'll call that a zone. So if anything goes wrong, everything in that zone is going to fall over. We want to have a backup. So one zone, power, network, cooling. Head nods? Easy peasy. From there, a region. A region is, hey, I've got some zones that are close together. In the cloud, the hyperscalers, this makes absolute sense. But it also works for the data center. Like, in the same building, I might have one zone with its own power, network, and cooling, and maybe on another floor or on another part of campus, power, network, and cooling. Multiple zones, and that's cool. But we'll call that a region. So if I'm in the same kind of geographical, if there's a storm or something like that, a region. Different regions is a good idea. Let's get our data someplace else. Let's have things someplace else. But there's also our customers. Where are your customers? Sometimes our customers aren't located in central US or south central US. Sometimes our customers, especially as we scale, they're on the other side of the planet. So what do? Well, we have some options. One of the things that, I want to convince you is that the idea of active-passive, the idea that, hey, I'm going to have a hot site, South Central US, if that falls, if anything happens, falls, we're going to fail over. This is the active-passive. I've got a hot data center, a hot zone, and if something goes wrong, it fails over to the other zone, other region. Active, passive. My screen's flashing, it's getting me a little excited. But one of the problems that I was faced with, one of the pains of my life, the scar tissue I was talking about, is back in the day, we're scaling millions of users. We're deploying in 47 languages around the globe. But all the traffic is coming back to one region. And in that region, we had 2 zones, hot and cold. And I was having to deal with this. I was the one that was ordering the servers 6 months ahead of time, having no idea what our capacity was going to be. But I had a whole data center sitting over there that was cold, waiting for things to fail over. We couldn't buy more servers. We couldn't buy more capacity. We were at capacity. We're going to scale for the holidays, but I have capacity over there that I couldn't use. So in that position, I felt like, why? Why do I have this budget? Why do I have this max capacity? Why am I worried about entering into the holiday season when I've got all the capacity sitting over there just waiting? Cold, waiting for the failover. And of course, I can admit we weren't one of those companies that was testing our failover. We weren't doing game days. So when it did fail over, it was taking hours to fail over. And our customers felt it. Like, oh, hey, yeah, data center 1, don't worry. It'll be up in the other data center pretty soon. That's a hard message to deliver to our customers. That's a hard message as somebody that takes pride in their work, not all my code, but pride in the work. That's a hard message. The other thing is latency is a new downtime. So if somebody's hitting that hot zone and it has to fail over, now they're waiting, that time it might as well be a layover. It might as well be an outage. Latency is the new downtime. How long do you wait for a page to load? And one of the things I'm going to try to say is resilience is better than robustness today. Resilience is better than robustness. So this would be the point where I say, hey, I've got scar tissue, I'm going to remind you, and you've got options. I would jump into my Terraform. There's a few pieces that I'm talking about here. Terraform, infrastructure as code. So because I can't show you, infrastructure as code. Is everybody familiar with Terraform? Terraform. Or even Java. There's lots of code that we can deliver. But one of the things that I like to talk about is everything as code. Your infrastructure, your code, your features, your config, all of your abilities, your scalability, observability, all those things as code. One of the things I hope I want to talk to you today is get away from ClickOps and move towards GitOps. So one of the things that I stood up minutes ago out in the hallway was my infrastructure. I stood up some Azure Spring Apps Enterprise, and I stood it up in 2 regions. 2 regions. But I'm only going to deploy an app to 1 region first. The minimum viable product. We got to get something out the door. The idea is, hey, as you're starting, as you're growing, yeah, 1 data center, 1 zone sounds fine. But as you grow, once you get past that, the idea of, hey, maybe when I start to scale, instead of scaling in 1 region, maybe I just scale in 2 regions, especially if I'm in the cloud. It's going to cost about the same. So just picture, if you will, you have a Kubernetes cluster. Region 1, favorite region, close to home base. And now it's time to grow. Hey, we want to make sure that we stay up. We're heading into the holidays. Mother's Day is right around the corner. So we want to make sure that we can scale. We want to make sure we can handle everything that's happening. So let's stand up another cluster. Let's scale up a little bit. When it comes to that point, think about putting it in another region. It's going to cost the same. It's going to protect you a little bit more. And this can happen at the zone level. If you're in a data center I just got back from a trip over in EMEA, and there's companies that are doing millions of dollars a year that are running on data centers that consist of 3 nodes. 3 hardware servers in a closet in their office. I've been around long enough for that makes sense. Right? I started with 1. But that idea, they're still delivering zones. They still have different networking coming into those computers. They're still doing the resiliency as much as they can, but as they grow, they're going to look for different regions. They're going to try to move closer to the customer. Another piece of this puzzle is cost. One of the things that I like to do is tear things down when I'm not using it. If I'm a globally scaled product, if I'm going around the globe, sometimes I don't need all my data centers up, right? If it's 8 to 5 here in the US, I'm going to scale up in the US during business hours. As business hours fade, I'm going to scale down in the US, and I'm going to start to scale up in EMEA, or vice versa, right? The sun goes the other way. But that idea, this is another aspect of what I'm trying to talk about in resiliency is better than robustness, and don't deploy active passive. If you can get comfortable with this idea of I'm going to bring my workloads and my data to where it needs to be, to where my customers are, that's a good thing. And if you're in a situation right now where you have active passive, you've got that data center, it really came down to money. It hurt me that I had this data center that I was paying for and not using. There was sleep lost. Outages don't happen all the time. But active passive data centers waste money every day. So we can improve not just the capacity, but also the resiliency without additional infrastructure expense if we're moving from this active passive to active active. And it doesn't take much. So the code that I was going to show you was, I like to use Redis. I worked at Redis. And the idea is like, hey, I wanted to show you like, hey, if I'm in the West, I'll hit the West and I'll see my data in the West. And if I write data in the West and I knock it over, I'll see it in the East. The idea of having this globally load-balanced infrastructure, that was a big part of my career. That once I figured out that I had customers all over the world or the country, and I wanted them to have the same experience, I was making different decisions. So the picture was a large load balancer that sat in front of everything. It's easy to stand up. There's lots of options. I was using Azure Front Door. And one of the things that we do with Spring Boot is it was one of the things that really allowed me to get excited about Spring Boot. The same time I'm struggling with active passive, the same time I'm struggling with, we're going to scale and I have no idea how, we're also releasing new features, releasing new microservices. And I'm one of those people, I've made my career out of making career-limiting decisions. And I surround myself with those people that have made career-limiting decisions. So what I was doing was I was getting these self-provisioned, self-service VMs. And I was kind of going around. I was deploying my own Spring Boot app that had the actuator built in. The actuator and the metrics that the actuator provided were a big deal. Just the health check. Just the idea that, hey, my app is up. Is my app healthy? Just that alone, having that metric was important enough for me to go around the rules, to make a career-limiting decision. I was deleting all of the infrastructure that was on that self-provisioned VM, taking only the certificates there and using those certificates for my Spring Boot app. It wasn't containerized. It was just running as a process on there. But it worked. It was in that time where I was taking apps and throwing them over the wall to the ops team, and they would tell me, hey, we got it from here. We're going to give you metrics. We're going to give you a dashboard. We got it from here. They didn't know what my app was. So I'm throwing my app over the wall. They're giving me a dashboard, and guess what? They're kicking it back. Your app is using 90% of its memory on that self-provisioned VM. 90%. Why are you kicking it back? Because it's using 90%. That's what our alerts are at. I wanted it to use 90%. That particular app had a buffered cache in it. The more data it had in that cache, the better it performed at scale, again, globally. And they were kicking it back. Oh, I was so frustrated. This is a problem for me. This is why I was going around. With my actuator, I had my metrics. I had my APM tool that I could tie in, and I was doing it myself. I'm not going to wait for your dashboards. I'm not going to use your alerts. I know my app because I wrote it. You know your app because you wrote it. Nobody can provide the thresholds better than you. And that we're in this DevOps turn, and the idea that, hey, I'm going to own that. I was going to take responsibility for that app. I'm getting my hand slapped. I'm going around. I'm circumventing the process. But I'm going to take ownership of it. And I was so happy. I was so happy. So now I had my own thing. I was going around. I was kind of circumventing that team. But I had Spring Boot Actuator, my metrics, and I was managing and monitoring. If something fell over, my APM tool said, hey, that's not healthy. I was restarting it. There was no 2 a.m. phone call. It was just handled. Again, pre-Kubernetes, pre-container orchestration. I was doing it. There's other ways around it. We've been doing this for a while. And it was great. The next problem I ran into was that path to production. I was kind of skipping the team that was on the other side of the wall for these apps. Well, I had the son of the CEO was an intern. So the CEO of the company actually knew where my office was. He came over and he said, hey, there's a typo. We all made that one. Not the. He said, can you fix that? I said, of course. I opened up my laptop, THE instead of TEH, the. It was subversion to give you some time frame, and off. I'm like, hey, it's done. I committed it, it's ready, it's gone. The next day, the CEO comes back, says, I thought we fixed that bug. Well, this bug was in one of the other parts that got thrown over the wall to the other team that took 2 weeks to get to production. I was comfortable on this path where I built my own automation. I was kind of going around the process, and I was building, and I was scaling my own thing. But on this side, where I was throwing things over the wall, it was going to take 2 weeks. Let's just say it was on a Monday. And that 2-week cycle was just starting when I made the edit. So the typo, wasn't going to get to production for 2 weeks. This is where this all comes back to. This is my pain. Spring Boot makes it really easy. I built this path. I had everything I needed in my Spring Boot jar, including my metrics. Well then, that's one thing. But now we're getting into the data. Right? Scaling in a zone is pretty easy. And I can say at performance, the things that I've dealt with over the years, one of the main things that I run into that I see customers having problems with is connection pooling. Whatever data system, whatever data store they have on the back end, they call, and the types of calls that I was getting was, it's a 2 millisecond latency, we need it down to 1. Anytime I hear that, the first thing I go to is, let's go look at your connection pooling. What happens a lot of times, hey, it worked. It worked when we were in one region. It worked for the MVP. It got to production with the defaults out of that container, out of that driver for whatever that data store was. It worked. Part of this mature process, part of this going from single region, active, passive to active is you've got to pay attention to those things. You have to pay attention to your configure. You have to measure, and having those actuators there really helps. The actuators and the auto configs that are provided with Spring Boot, they provide a lot of those metrics that you can see out of the box. You don't even have to configure anything. Add the starter, add the actuator, you're going to get a lot of that information. So now we're scaling. Data is the key. How do we handle the data? For a long time, how many of you have heard of service mesh? real popular. Like the idea is like, hey, I can just access anything wherever it is in the globe, global namespace, amazing technology. But I said earlier, latency is the new downtime. If you're a company that's making money per transaction, millions of transactions per day, and you're running into a 2 millisecond latency limit, hey, we want to do better because we're making money on every transaction. And if we could do 1 millisecond transaction instead of 2, we could make twice as much money. Think about that. The idea, here's a metric I want you to think about. Cost per transaction on your data store. Cost per transaction. So I'm going to bring it back. Data is a big problem. Active passive is what we were doing. Big RDBMS. The one that when you need to scale, they say, hey, here's your $20 million bill. It'll be set up in 6 months for 5% increase in capacity. You know what I'm talking about. This is painful. So from that pain, I've kind of grown. There was a session yesterday about Yugabyte. Being able to have my data geographically partitioned and resilient. There's tons of options. It's 2023. Before we had service mesh, we had companies like Facebook, and we had things like WebScale, Mongo, right? Remember the WebScale? Is it WebScale? Just me. But we had these technologies. That's how things were being handled across data centers and across the globe. It just started with the data. We figured out how to do this data replication. Sometimes it started as leader-follower pair. All the writes are going to happen on one spot. If something fails, it's just the database that's going to fall over. Hopefully that failure database is in a different zone. Low latency between the two, but that idea, that got us a long way. That got us through the aughts, early 2000s. Leader-follower pair. And then we grew, and data became more important. Cassandra was kind of like the go-to thing for a long time. Mongo, of course. But now there's more and more options. Yugabyte's amazing. Yugabyte is doing this at scale with RDBMS, like with relational data. It's magical. I worked at Redis. I lean into Redis. I focused on those low latency issues. And that's important. So the idea of moving from one data center, do I want to scale up and add that $20 million bill to get 5%, or can I scale out? The idea that I can go into a different region, into a different country, closer to my customers, and I can scale, I can be fluid across those regions with my data. Mid-2010s, 2015, I don't remember when GDPR came on. I think it was around 2015, right? 2014, 2015, where our data now needs to kind of live in a region. We still want all the capacity, we still want all of our customers to have everything, but now we've got to worry about where their data lives. Yeah. I mean, we're good here. That idea becomes more and more important. So this picture in my head starts with that load balancer up front. In my company, we just had those kind of 2 data centers in one region. I was like, oh, if I could just make that happen. Spring Cloud Gateway came on to the scene. It wasn't a global load balancer, but the idea that I could route traffic, I could have discovery behind that gateway in 2 data centers, that was magical. Even for that one use case of that buffered cache. If I could get a gateway in front of it and just, it was falling over. My APM was restarting it. Like I had that, but if I could do it in multiple zones, if one did fall over, I was okay. So it's not just about when failures happen. The active-active approach also works with just the day-to-day operations. How many of you are releasing once a day or twice a day or more? You've heard about Kubernetes. I think it's going to be around for a little while. The idea that Kubernetes gives us these advanced deployment strategies. I can do a canary deploy. I can push out a test into a single region and validate it before I push it out to the rest of the globe. This is also important with an active data set, active data store. I can do deployments. I can have things spinning up, spinning down. And that traffic, with a good load balancer or a good gateway, will route traffic to something that is up and healthy. So one of the things that we need is that load balancer's got to be able to determine if your app is healthy or not. Spring Cloud Gateway with the service discovery can do that. You kind of get it out of the box. It won't route traffic to something that's not healthy. But again, every cloud has something similar. Oh, look at this. Awesome technology. So now let's see. Where should we pick up? Let's show how easy it is. Like, if I want to stand things up, I'm using Terraform. I'm going to make all this is available on my GitHub repository. Let's jump over there. 45 minutes ago. Again, it's a problem, I know. Like, I can't leave things just unattended. I was making changes 45 minutes ago. So that is here on my GitHub. I'm at DaShaun. And yeah, I don't like spending money on infrastructure that's not being used. So when I stand up something by default, let's jump into here. I stood up Azure Spring Apps for Enterprise. I put some of my stuff into Central US. And I've got these pieces. I have some app insights. So I already talked about throwing my app over the wall. And they're going to decide what the thresholds are for my application. Wouldn't it be nice if before you get to production, you could say, hey, here's my threshold. Here's the things that I want to see on my dashboard. Maybe it's not connections per second. Maybe it's not percent memory consumed. Maybe it's the number of items that are abandoned in a cart. Maybe it's the number of tweets per hour. I care. It's my metrics. It's my app. It's the things that I want to see on my dashboard. So out of the box, on your path to production, I want to have a way to see my own metrics. I want to have a way to consume my own metrics. Because I wrote the app, and that's what I want to see. So I put application insights. I use Azure Spring Apps, which is Kubernetes under the cover. I'm a big fan of cloud-native build packs. The idea, my good friend over here, Dan, we like to say that friends don't let friends write Docker files. If you're running into a Docker file, if you see a Docker file in your repository, I want you to think. Just take a pause. Breathe in. It's okay. We've all been there. But I want you to look at cloud-native build packs. The idea at scale, hundreds, thousands of apps. If anything changes, if there's a CVE, if I've got to make a config change, if I've got to change a JVM option, if there's any of those changes, I've got to go and edit that Docker file and then redeploy it. One of the things I get out of the box with Azure Spring Apps is under the cover there's a thing called Tanzu Build Service. A container is made up of layers. Okay, we start with some base operating system, then we run some app runtime, like a JVM, and then our application code, or jar file. And there's many ways to do that with a Docker file. I don't care. I don't want to deal with it. So Cloud Native Build Packs kind of takes an upstream approach where we take the best practices of everything, just give me your source code, and I'll take it from there. The Cloud Native Build Pack has a detect and a build phase. So it'll look at my repository. If it sees a pom.xml, it'll say, oh, I see it's a Maven project. If it sees a build.gradle, oh, great, okay, I know how to do that. And more. I can stack these build packs for my CA certs, for my APM, my App Dynamics, or my insights. Also for like open telemetry. So I can stack all of these things, and I don't have to worry about a Docker file. And with something like Tanzu Build Service running on Azure Spring Apps for Enterprise, if something changes in the base layer of my container, that base image, the operating system, the Alpine or the Ubuntu, if something changes in there, I don't have to go and rebuild everything. I can say, hey, my system knows that all these apps are running with that compromised base layer, and it can go with a Cloud Native Build Pack. It can replace just the base layer. That's part of the Cloud Native Build Pack spec. Everything is put into a specific spot. So if I need to replace that operating system, I can replace it with a new version at runtime. Active deployment. I didn't have to fire off any CI/CD. The platform took care of it. This is a nice feature at scale. That's why I like to use it. But here I stood up 2 different regions. I said, hey, Central US and South Central US. I said, hey, I'm going to deploy some apps. Basically, it's a Kubernetes cluster under the covers with some nice bonuses, integrations with the logging system and the metrics and all that. And that's how I'm going to start. For my simple app looks like this. I could have gone to start.spring.io, built something really simple. I'm just going to say hello. And in there, I'm going to say hello from my region. So I'm going to deploy this simple app. All this app is doing is saying, hey, what region am I in? I'm throwing that as an environment variable, as a 12-factor, 15-factor app. Keep your configuration next to your apps. Get it from the environment. That's another feature of Spring Boot, Spring Cloud, the Spring Cloud config. But here with Azure Spring Apps, it's deploying it as a config map. So my configs land in my app just the same. So I deploy an app, and I'm not going to do it because we're on time here. But let's run. This is the app that's running. Hey, hello from the Central US region. Cool. What does that mean, DaShaun? Like, hey, yeah, you got an app in the Central US region. The next step is like, hey, well, I talked about active passive versus active active. So I do all the magic, and I show you, hey, look, let's make sure my app is running in South Central. So this is great. But what I don't want is my user put something into their shopping cart, they hit South Central falls over, and then they go to Central US, and their items aren't in their shopping cart. I want to make this work. I want to make this resilient. I want to make a good experience for not just me on the ops side, on the developer side, but also for my customers. It's funny, but that's what we're here to do. You know, make money, save time. That's a good value prop. So now I've got these 2 things. So what should I do? I talked about this global load balancer. So one of the other things, again, I did Terraform. I kind of default to Terraform for everything. I used Azure Front Door. With Azure Front Door, I said, hey, here's a route. Here's the name of it. In the back, I'm pointing. So I put a gateway. I put a load balancer, a global load balancer. I could do this in any region. I said, I want all the traffic to come through this front door. And that front door is going to look at the different back-end services that I have. So I've got one in Central US, and I've got one in South Central. And the load balancing is handling it. I've got some settings, hey, timeouts, and then here is the front end. So now, instead of going to South Central, I've got to centralize load balancer. And hopefully, one of these times, it'll hit the other region. South Central, it's not hitting the other region, but that's okay. It's not hitting the other region. But the idea is I'm driving all that traffic through a load balancer. That load balancer is checking. Maybe something is wrong. Let's go take a look. Maybe something is wrong with that app, because if the load balancer says, hey, that app's not healthy, I'm not sending traffic to Central US. So let's go take a look. The funny thing is, we just saw this. I hit refresh. It looks like it's working. I can do this. Uh-oh. Did I not expose that? Oh, yeah, it's not exposed. So yeah, cool. But it's up and running. That's good. Let's go take a look inside of Azure. Let's see if we can find the right region. The resource groups, not that one. I think it's this one. Again, there's my insights, my apps. Let's look at that central app. This is kind of what I get out of the box. That APM that I had back in the day, I kind of got it out of the box. I got it with my Terraform. I've deployed this. I can go in and look. My app is here. And it says it's up and running. So perhaps it's just a load balancer deal. I have no idea how I just did that. There you go. So the next thing I would do, like this is just a simple app. It's not doing anything special. I want to upgrade that app. Let's see if we can do it real quick. I want to upgrade that app. I want to use Redis. Let's make some quick changes. Let's see if we can beat the clock. With this, I'm going to deploy Redis Enterprise. Redis Enterprise under the covers. Let's go take a peek at that. This is what I already talked about. Stop doing this. I want you, if you've got spare compute, you've got spare infrastructure, you've got cold infrastructure, I want you to start thinking about why. Why are you paying for that? Why aren't you using it? I want that to bring you pain from here on. I want you to think about why are we doing it that way? And there's some use cases where that makes sense. There's some use cases where that active passive makes sense. It's going to be in a region. Again, I just came from EMEA. They're worried about war, right? So they're worried about, hey, how do I get my stuff? How do I have a backup in case data center 1 and data center 2 aren't there tomorrow? And these are real problems, very different, heavier problems, but there are some use cases where that makes sense. We've got options. Yes, let's convert it to active. And it's always a negotiation. Like, what are the trade-offs? So in this case where I've got another Kubernetes cluster, instead of just scaling up one app, I scaled up another Kubernetes cluster in another region, but now my resilience is better. And as I scale apps in those clusters, again, I have that additional resiliency. I'm going to make changes over here. I'm going to add a starter. I get it out of the box. I'm going to, of course, update my tests. I see the red up there. I'm just going to try to hurry. Color. I have something that's duplicate. Oh, I don't have this. And it's just this. What else? Low. The ID is catching up. And comment that out. So what we're doing here, when I hit that page, I'm just going to take a key and say, hey, you hit this region and throw it into my data store, which is Redis in the backend. Key value store in this example. Cool. Let's run our tests and let's build it. Just make sure everything's running. And now it's going to look for Redis in the back. Oh, hopefully. Oh, I got to format. Because that's what we do, right? No problem. So now while that's building, let's go and let's add to our app instance. Let's connect it. It shouldn't be that difficult. The idea of how long does it take you to get a database? Like, I've been spoiled over the years. I've been spoiled where I had a platform where I could just say, hey, give me a database. CF create service, MySQL. And my platform team was awesome. The minimum plan for a MySQL database was a leader follower pair. And that leader follower pair that was deployed into different zones at a minimum, because they've learned a lot of times we're building things that, oh yeah, it's just a one-off project, and they end up in production and being a crucial part of what we deploy. So why not just cover our bases from the beginning? So I've been spoiled. And I'm spoiled again. I like that experience. It shouldn't take days or weeks or months to get a database. And a lot of times when you have a process like that, once you get a database, you hold on to it. I like to delete stuff when I'm done with it. I like to have a situation where stage and integration, they're not up all the time. Again, maybe it's just my time in startup. I like to get rid of things. I like to be able to scale things down. If nobody's in the building, if nobody's doing testing, why is stage up and running? Just do that quick math. You had a production cluster X. You have a stage cluster that 2x. Now you have a dev cluster 3x, whatever it is, whatever that looks like. If nobody's doing development, if it's Sunday, why is development up? Why is stage up? Just turning things off when you're not using it can save you a boatload of money. Coming back. Why do you have a passive data center? You're spending the money. Use it. Or better yet, maybe that passive data center could be used as your dev and stage. Use the infrastructure, turn it off when you don't need it. That's why I like infrastructure as code. One of the things we get from the cloud is not really affordable. It's not cheap, but you can turn it off. You don't have to buy it 6 months in advance. You don't have to worry about it getting updated or outdated. If you're delivering as code, you get that agility. So, this attached to a database. I deployed my Redis Enterprise. I deployed it with Terraform. The Terraform is simple. Looks like this: deploy a cluster. Deploy a cluster. I've got one in region 1, Central US, and region 2. And then in there, there's a database. The cool thing about this is I can add 5 of these databases, 5 different regions across the globe. I like Azure because they've got a lot of regions. For public cloud, they've got the most, I think. So I can take this database, this data store, I can put it wherever my customers are. And now I can just attach to it. My app didn't change. The app that I just ran locally, just Redis, give me some Redis credentials, that works. The same on my laptop, and the same when I push it to the cloud. So let's push that to the cloud. Let's push, we're gonna run. It's gonna take a little bit. Because all I'm gonna do is, I'm gonna say, hey, here's my code. Here's a cheat code. If you guys do Terraform, this is one of those cheat codes I like to do. In my outputs, I like to provide the commands. So the output tells me, hey, these are the parameters that you're gonna need to pass in on the command line, so I can do the things. So I'm just putting those in, so all I've done here was I said, hey, go run that build deploy. So it populated it with values that it got from the Terraform output, and that's what it's doing. So now, the value that I gave it was just my source path. I didn't give it any container, I didn't give it anything else. I just gave it my source, my repository. So this could be a CI/CD pipeline. Hey, something's changed, here's my source code. I've given my source code to the platform. That's all I'm doing here. I'm not configuring anything. Actually, let's go look at that config. I have an app. It looks like this. Nothing special. It just says, hey, it's part of this region. It's part of this Azure Spring Apps. And that app has a deployment. In that deployment, I can pass in the region value. That's what we were seeing, Central US versus South Central. And that's it. I'm giving it the time quota, how it's going to scale the rules. I've got 2 of those. So now that's happening on the back end. It's going to go take care of it. There's a build pack that is running. It's looking at the source. It's looking at, hey, do you need certs? Do you want to deploy it to Tomcat? Do you want App Dynamics attached to it? And it's handling that for me. And then in my platform, I've attached it Enterprise. And the Enterprise is configured with active, multi-region, multi-cloud. And it looks like this. This is how Redis works. The differences in these cloud scale data stores, they all have a different approach. They have different wins, different strengths for different use cases. So I always like to ask, what's the use case? Redis's use case is when you want millisecond response, millisecond latency, this is what you use. The reason, a write happens in whatever region that write's going to do. It's got another replica in the same region, in a different zone. From the replica, it gets a copy. The replica writes to a leader in another region, and so on and so forth. So if a write happens over here, it gets replicated in the same region, and then it goes over to the other region. But again, this can happen at scale. In Azure, out of the box, you can do it in 5 regions. The last I checked, it's at least 5 regions. But if you're a company that's doing millions of transactions per second, this is kind of what you default to. That low latency response, active around the globe. So that's what it looks like. Typically, it gets across region in 15 milliseconds. Going fast. So this is what our app looks like now. So I just deployed an app that's going to connect to this data store. I have apps deployed in 2 different regions. They're both taking traffic. The thing that I've duplicated, the biggest expense that I've duplicated is that data store. As of right now, I just got one app. But think about this. I can go and destroy a region. There's a 15 millisecond window where something could have gotten written to one region and not made it over to the other region. It might have gotten replicated first, depending on how you set it up, and it'll get written to disk. But that's a really tight constraint. And at scale, it really works. It's really great. So my data, written here, central region, south central region, if it falls over, my shopping cart, my bank transaction, it shows up in the other region. It's there, it didn't get lost. So instead of thinking about service mesh, consider using the data store to do your replication across regions. There's lots of options. Redis Enterprise is just one. This is what it'll look like. So it's taken a while. Everybody shut off your Wi-Fi. Maybe it'll go a little bit faster. Just kidding. Yeah, let's keep on going. I'm not going to stop there. I'm going to talk about some of the things I don't want you to do. Yeah. Stop doing that. I don't know why it skipped over. That's right. We'll call it good. Actually, no, let's do one more thing. That app is deploying. Let's go ahead. This is the magic. Let's go ahead and just delete a region. This is the key. Like, hey, things happen. I'm going to delete that region. And I'm going to be comfortable. I have an app deploying. But still, this is going to happen. Things are going to happen. And if this was active-passive, I'm going to have to wait. If this was my hot region, I'm going to have to wait. But because I'm active-passive, I'm expecting that things are still going to work. And I feel good. So there. My region's destroyed, and my app is still up and running. So now I'll leave it for questions. Thanks. I'm DaShaun. What did you think? Sorry about the technical difficulties. You have a question? Yeah. Yeah. There's different solutions for different data stores. So the question is, what's that? Yep. The question was, what about Microsoft SQL Server? How would I do something like this with Microsoft SQL Server? So there's one approach that I've seen, and the addition is like, what about the transaction? So I talked about the kind of leader follower. Again, I don't know if I had my slides back then. But that idea, I can do that leader follower approach. I can do it across regions. Hello. Why am I not seeing that? I can do it across regions. So there's a process called change data capture. So for the MySQL Server use case, I can have region 1, hot region, hey, writes are happening here, write it to its follower pair in the same region, but I can also tail on the logs. And there's a bunch of different tools that we can do that, and I can send it over to another region. The problem that I can't do with Microsoft SQL Server is I can't do an active-active write. But I can have that same relational database with something like Yugabyte. So if you saw that session yesterday, so it won't be Microsoft SQL Server, and you can transition from Microsoft SQL Server to something like Yugabyte using a change data capture to give yourself a nice transition. So it's a problem that a lot of companies have. Like, how do I scale this relational database? So I'm going to put these 2 words into your head. Change data capture. Depending on how you're going to approach it, you can do change data capture, you can take it to something like Yugabyte. But there's also these kind of event-driven approaches, something like Kafka, where maybe I want to capture all of the writes that are happening, and I want to do like a write behind. So I can do a write behind to multiple places and keep, because I'm using Kafka and it's got a log, I can keep all of those writes. So depending on what your use case is, there's different approaches for each, but there's approaches. It is 2023 and there are approaches. Your data store can run active-active across different regions and even different clouds. It doesn't even have to be in the same cloud. So this example, I could run a Cassandra, I could run a Redis Enterprise in Google, in Alibaba, and in Azure, and I could do the exact same thing. But hopefully that answers your question. There's approaches, but yeah, there's different use cases, have different strengths, different weaknesses, different things they're trying to accomplish. So what's the most important thing? And you kind of work down from there. Yes? Yep. Their conflict management is, it's a similar process to what you find in Cosmos. Timestamps on each data type. Redis, for those of you that don't know, has multiple data types. The key value store, it's got lists, sets, ordered sets, and it's got additional modules. But each data set, each data type that Redis supports has its own conflict resolution scheme. So if I'm in one region, there's a process where it says, hey, I see that I have these writes for the same key, and it'll evaluate on the timestamp, but you can configure that as well. So out of the box, each different data type has its own scheme, but it's also configurable. Good question. Any others? Awesome. Well, my name is DaShaun. Thanks.